Welcome back to linear algebra. Let's jump into hockey. Alright. If a certain sequence of elementary row operation produces an n by n matrix A to the identity I, what effect does the same sequence of operations have on the matrix I? It gives you the inverse of A. What can you say about the number of solutions of a linear system AX equals B for which the coefficient matrix is invertible? It's exactly 1. X equals the inverse of A times B. That's the exact one. What can you say about the number of solutions of a consistent system of linear equations? Either a 0, 1, or infinitely many. Suppose that A is an invertible n by n matrix and B1, B2, Bn are n by 1 column vectors. What information does the reduced row echelon form of the partition matrix provide? The partition matrix A, pipe B1, pipe B2, pipe pipe Bn, pipe, it solves all of them. It solves for B, at the same time it solves for B2, it solves for Bn. The last n column vectors in succession are the solutions of the systems AX equals B1, AX equals B2, AX equals B3. Solutions. Oh, they're X. Okay, I messed up. A diagonal matrix, what is it? A diagonal matrix is a matrix in which all the non-main diagonal entries are 0. Suppose that A is an invertible n by n matrix and B1, B2, Bn are n by 1 column vectors. What information does the reduced row echelon form of the partition matrix A, pipe B1, pipe 2, B2, pipe Bn provide? Provides the solutions of AX equals B1, AX equals B2, AX equals AX equals Bn. Okay. I don't think there's anything to grade. This was just a showing. Not a proof, but a verify problem. So say this is good. Alright, so I'm gonna go do some more practice problems, work and plug in more Anki flashcards, and I'll be back in a little bit to recall what I did. Alright. We did 1.3 a review problem 34. Gave two matrices. It says what does M minus J represent? May was sales for certain items, J was sales for certain items. So it's the difference between May and June sales for certain items. This one was another verify. So here's theorem. This theorem was the inverse of a symmetric matrix is symmetric. And so we showed it for that, for this matrix. 39. Find A that satisfies this upper triangular matrix, and I don't know if there was a shortcut or like a rule for this, but I just went ahead and multiplied. I plugged in variables for the A, multiplied them out, and then solved the systems just for the variables, and then got this as A. And then this last one we learned about skew symmetric matrices, which is the transpose of A is -1 is negative A. I'm not really sure how that's possible when the main diagonal doesn't change. How the hell does it become negative? All right, screw it. We're gonna do 41 first because it's the first question on skew symmetric, and then we'll do 43 later. So we'll do that tomorrow. I finished up the last of the Anki flashcards I needed to make. So now we're all caught up to the current unit. So that's it for today. Talk to you tomorrow. See ya. Make.com. Today I finished the use case for rejects, the bottom pathway, in which we use a text aggregator to aggregate the different elements. Then we use some functions and a set multiple variables to pull out, extract the individual elements from the text, the single string, and then we go ahead and upload those to a Google Sheet. I believe that's pretty much it. We should be done with this unit tomorrow and into the final unit on using regular expressions. And yeah, so this has been a long unit, but we're just about done. So should be done tomorrow. Talk to you then. See ya.